Hello everybody, um, welcome back to another lesson. Today we're going to be finishing up this chimney assembly class. I added some comments, and we're going to actually add something else after we finish it, and which will make this coal grate part make more sense. So yeah, that's it. So let's start. Let's go down to draft. Okay, so we're going to create a pipe that goes from here down to something called the draft fan. The fan, basically, there's going to be a system of pipes that we're going to build. I already built part of it. It's like this down here. So the smoke from the coal and fire goes through here, and then the dust goes down here. The smoke goes up here and into there, down, and then goes to another thing. The fan is what powers everything, so the smoke actually goes in here, right, and follows the correct path. So that's how we're gonna build it. So let's start, obviously, by finding variables like we did many times before. Fan top Z. I actually turned on caps lock. Fan top Z is equal to up top Z. So this Z level is gonna be the same as this, I think. Or maybe that. Fan bottom Z is grate. Oh wait, no, this is the thing that goes down. Okay, so it's this is the top Z is down and the bottom is grate. Top Z, so the pipe goes from there down to there. Sorry. Fan length is fan top Z minus fan bottom Z. The length top minus bottom, that makes sense. And then the mid, we take the average of the top and the bottom. Fan bottom Z divided by 2. Fan Y is horizontal mid Y plus horizontal length divided by 2. So that's the minus self dot pipe radius to get the middle. I spelled self wrong. Horizontal 2 is this, the mid of that, plus the length, which get here, divided by 2, which we get the end of this pipe, and then you subtract it by the radius, so it's a little bit, just a little bit, behind the end of this pipe. Fan X is up, branch X, fan vertical geometry dot cylinder. So we have all the things we need. We can put them into the chimney. Oh, I can't spell chimney. To fan vertical. So the pipe radius is the pipe radius, the length is, we'll define that. These are all the all the variables for the dimensions, rotation, well, it's vertical, and if you remember, 0, 0, 0, and then we can append the fan. fan mid Z is not defined. Fan, where is it? Fan mid Z is equal. There you go. It looks kind of weird from here, but it looks much better. Up here it looks more smooth. And obviously, if your personal preference doesn't like it, you can change this equation to change the y. So if you don't like the pipe radius, we can do that, and it's gonna, yeah, shift outwards. So do what you like with it. Now, draft fan cylinder laid on its side to represent fan housing. So we're going to create a cylinder over here. That's gonna, like, the face of the cylinder is gonna face you. So if going to X, this is gonna be a circle here, and then it's gonna be a rectangle for a cylinder. That's the way the cylinder is gonna face. So we actually have lots of the variables we need. We can just borrow some from over here. What we really need is the radius, but we have from the fan diameter, from the initiation, and obviously the center, which is the ash z, and it's slightly higher, so it's plus 0.05. Draft fan radius. So everything we defined, fan x, fan y, is the same as the pipe. Only the z is different. Rotation, and it's on the side. It's rotated, however, it's rotated uniquely, so that it's actually rotated on the y-axis. And you see that, like I just explained. It's not plus, it's equals. And yep, you see, that's like these two, oriented like the boilers, right? Because the pipes, which we used the 90 radians on the x-axis rule, the pipes are rotated like this, or like that. This is rotated like this, which is like neither. So we rotate it on the y. Now, the only problem with this chimney is that we don't have a chimney. It's just pipes, collector, yeah, no chimney. So we can fix that. How? We're gonna make a pipe extending from here and then a chimney. So let's build that. So ground level horizontal pipe from fan to chimney base along the positive y-axis, because there's a negative y-axis, like this way, positive is like that way. You can see by, yeah, negative y, positive y. Ground pipe mid y is fan y plus self dot ground pipe length divided 2 plus 0.2. Oh, I didn't have to run that. Ground pipe mid is fan X, ground pipe mid Y and center. I didn't have to run that too. Ground pipe is geometry dot cylinder. Ground horizontal pipe self dot pipe radius self dot ground pipe length ground pipe mid. The rotation is horizontal, so 90 radians. Oops, something happened. And it's over here. I see what's wrong. I misspelled things. There we go. Oops. And I definitely forgot to write the form. Now, finally, we can build the tall chimney, the end of the ground into a vertical cylinder. So you already know that the rotation is going to be 0, 0, and 0. So first, X, Y, and Z are the chimney Y. It's going to be the ground pipe mid Y plus the ground pipe length. To get the end of this, first divide by 2 to get the end of the pipe, and then we add a little bit plus 0.2. Ground pipe mid fan X ground pipe mid Y, and then the center Z, so only the Y really changes. Ground pipe, and that's it. We can use this ground horizontal pipe. We already have the pipe we use from the initiation. Ground. Oh wait, I got confused. Yeah, okay. I thought we were gonna make the ground pipe again. Oops. So, chimney X, well, it's not much different actually. I just got carried away because I thought we were gonna make the ground again. Chimney center Z, fan center Z, plus self dot chimney height. Tall chimney self dot pipe radius times 2 self dot chimney height, and the dimensions I can put it in. Chimney center Z, rotation, it's vertical, so yep, and then append into the chimney height. Why do they call this ground pipe? What? Anyway, it's supposed to be called chimney. Now, return, because we have to return things for the class, and we just need to put like the pipes and stuff in here. So down pipe. Make sure to put commas because that's important. Okay. Here is everything you copied if you want. Okay. Now let's build the grate I was talking about earlier in this video. The grate over here, which is slightly tilted. Second grate placed to the left and tilted. So first let's find the center of this tilted grate. Grate dot center. That x. Grate dot center. Dot y minus the grate width. So the y is one of these grates over. And then the z is the same. Tilted grate is, we use the grate class still because it's grate. Center is the center, we use the thing. These slots equals tilted grate dot build, but we don't have a tilted grate. Actually, never mind. Actually, yeah, no, we do. So grate, we used grate build function on this grate. Yeah. Height different is 1. So now we're just like defining the how we're gonna make it tilted. So we already have the grate built. Now it's tilted. So height difference is 1. So this is like how steep the slope is basically. And equals length tilted slats. So this number of slats. For I slot and enumerate the tilted slats with a fraction, and I fraction across the grate. 0 is the leftmost and y not 1. Y 1 is the rightmost. T is I divided by n minus 1, so it goes from 0 to 1 as a fraction. The I is this like number of slats. No, I is like the slat. This is the number of n is the number of slats. And yeah, it's gonna go from 0 to number of slots. Z offset as height difference times 1 minus t. So the height difference between two of them, the offset between the slats, is 1 minus that fraction. So if it's larger, if t is larger as a number, the offset will be smaller. The offset will be, yeah. So now we can apply it. Slat dot location dot z plus equals z offset. Okay. Let's see if this height difference. What? Oh, is the indent slightly off? Okay, the indent is slightly off. And there we go. Here's the tilted grate. Now finally, we're going to make an ash cart copy. So, and you'll see why. Ash cart copy is chimney objects ash cart dot copy ash cart copy dot data is ash cart copy dot data copy. So that's making the unique. The name is ash cart copy, and then the objects dot link ash cart copy, and I use different quotes for this so this won't work. So ash cart copy dot location is 6.5. No, it's not equal. It can't be equals. And okay. Did anything change? No, but we made the copy, and that may be important later for next lesson. And yeah, see you then. Bye.